right there. That empty patch of stars you're looking at right now, that's where it was hiding. 10 million stars packed into one glowing ball of light. And buried somewhere inside it, something invisible has been sitting still for billions of years. Astronomers just found it. And what it means is a lot bigger than one discovery. This is Omega Centauri, the biggest, brightest star cluster in our entire sky. You can see it without a telescope if you know where to look. A smudge of light so dense it looks like a single glowing star. It's not. It's 10 million suns, crammed into a space you could cross in about 150 light years. People have been staring at this thing for thousands of years. Ancient sky watchers logged it as a single star. Even modern astronomers for most of the last century treated it as just another crowded ball of stars. Nothing special going on at the center. Turns out that was the biggest mistake in its entire observational history. For decades, something about this place didn't add up. Basic stellar physics says a cluster this massive, this old, should be a graveyard. Not for people, for stars. Big stars die violently. They collapse in on themselves, and when they do, some of them leave behind black holes. Do the math on 10 million stars, and models predict Omega Centauri should be hiding thousands of them. Some estimates say close to 10,000 black holes. And for years, astronomers had confirmed exactly 0. Not because the black holes weren't there, because finding one is nothing like finding a planet or a new star. A star gives off light. A planet reflects it. A black hole does neither. It's a hole in the geometry of space itself, and the only way it announces its presence is through what it does to everything around it. That's the problem with a black hole. It doesn't shine. It doesn't glow. It bends light around itself and swallows everything that gets too close, including the proof that it's even there. Most of the black holes we've ever found were spotted because they were feeding, ripping material off a companion star and heating it until it screamed out X-rays we could detect from Earth. But a quiet black hole, one that isn't actively devouring anything nearby, gives off nothing. No light, no signal. You can't point a telescope at nothing and call it evidence. So instead, scientists had to get clever. They stopped looking for the black holes directly. They started watching the stars around them instead. In 2024, that patience paid off. A team using the Hubble Space Telescope combed through more than 500 archival images and tracked 7 stars in the very center of Omega Centauri. And something was wrong with them. They were moving too fast. Fast enough that by every normal rule of gravity, they should have been flung out of the cluster entirely, gone forever into deep space. They weren't. Something was holding them in place. Something massive, dense, and completely invisible. The only object in the universe that fits that description is a black hole. And based on how hard it was pulling, this one had to weigh at least 8,200 times the mass of our sun. That's not a stellar mass black hole. That's not a supermassive monster like the one sitting at the center of our own galaxy either. It's something in between. A size class so rare astronomers call it the missing link of black hole evolution. Only a handful of candidates like it have ever been found anywhere in the universe. The method echoed something astronomers had done once before, on a much bigger scale, tracking stars looping around the invisible heart of the Milky Way to prove Sagittarius A was real. Except this time the target was smaller, dimmer, and thousands of light years closer, so that solved part of the mystery. One giant hidden object confirmed sitting at the core. But remember the other number. The thousands of smaller black holes the model said should be scattered through this same cluster. Those were still missing, every single one of them. Until a few days ago. A different team went back into the archive. More than 20 years of Hubble images, layered together with brand new data from the James Webb Space Telescope. They weren't hunting for a glow or a flash. They were measuring something almost absurdly small, the tiny wobble of a single star's position, shifting year after year, a fraction of a pixel at a time across 2 decades of photographs. It's a technique called astrometry, and it only works if you have patience. Most researchers don't. You need decades of clean, consistent images of the exact same patch of sky, taken by the exact same telescope, just to notice a star drifting the wrong way. And buried in that motion was a signature. One star, orbiting something they couldn't see. Something with a gravitational pull too strong, too concentrated, to be anything except a collapsed stellar core. They just confirmed it. The first stellar mass black hole ever detected inside Omega Centauri. It even has a name now, Omega Cat BH2. If you're just here for the headline, that's already remarkable. The first missing piece, finally accounted for. Before we get to why this one detail changes the whole story, if this is the kind of discovery that pulls you in, that's exactly what this channel does every week. Hit subscribe because the next one might be even stranger than this. Here's where it gets uncomfortable. A previous study on this exact same star system had a different explanation. They thought the invisible companion pulling on that star might be a neutron star, the ultra-dense corpse of a star that collapsed, but not quite far enough to become a black hole. Close, but different. A smaller kind of extreme. The new data killed that idea completely. When the team recalculated the mass using 2 decades of precision measurements, plus the sharper eyes of James Webb, the numbers didn't leave room for a neutron star anymore. Whatever is out there is too heavy. It has to be a black hole. Full stop. And that's the part that should unsettle you. This isn't a one-off. This is proof of concept for the other 9,999 black holes the models say are still out there, in that exact same cluster, completely undetected. We just found the method that can finally see them, which means the first one wasn't the end of the search. It was the first confirmed casualty of a search that's only just begun. Think about what that means for a place like Omega Centauri. 10 million stars, all bound together by gravity, orbiting a common center, and threaded invisibly through all of it. An unknown number of collapsed stellar corpses, each one capable of tearing apart anything that drifts too close. We've been staring at this cluster for over a century, cataloging it, photographing it, admiring it as one of the most beautiful objects in the night sky. A jewel box of 10 million points of light. And this whole time, it may have been one of the most dangerous places in the galaxy. And we simply didn't have the tools to know it. Picture standing at the edge of that cluster, if you somehow could. 10 million points of light stretching in every direction, closer together than anything in our own stellar neighborhood. And scattered invisibly through that light, gravitational traps with no warning label, no glow to steer around, nothing but a slightly bent path of starlight to give them away. From a distance, it's the most beautiful object in the night sky. Up close, it might be one of the deadliest volumes of space human eyes have ever admired. There's also a deeper question this raises about what Omega Centauri really is. Some astronomers don't think it's a normal star cluster at all. They think it might be the stripped surviving core of a dwarf galaxy. One that got too close to the Milky Way a very long time ago and got torn apart, leaving only this dense knot of stars behind as the wreckage. If that's true, then an intermediate mass black hole sitting in the middle of it isn't strange. It's expected. Every real galaxy seems to have one buried at its heart, including ours, which would mean Omega Centauri isn't just a cluster with a black hole problem. It might be the leftover skeleton of an entire galaxy that the Milky Way consumed piece by piece, billions of years ago, and we've been looking at the remains this whole time without realizing what we were seeing. So here's where we actually stand. One confirmed intermediate mass black hole at the center, roughly 8,000 times the mass of our sun. One confirmed stellar mass black hole, just found days ago, using a method precise enough to catch a star wobbling by a fraction of a pixel across 20 years of photographs. And somewhere out there, thousands more, still completely invisible, still unaccounted for, still waiting. The astronomers who made this find already know what comes next. They're going back into the same 20-year archive, hunting for the next wobble, the next star that's moving just slightly wrong. Because if the method worked once, it can work again and again. 10,000 times, if that's really what's hiding in there, one patient measurement at a time. We spent decades staring at Omega Centauri and seeing only starlight. Now we know what was staring back the whole time, patiently, invisibly, from somewhere inside that glow. Every photograph ever taken of that cluster, going back over 100 years, already had the answer buried inside it. Nobody had the technique sharp enough to read it. Now we do. And that changes what every old archive of every star field we've ever photographed might still be hiding. The question isn't whether the rest of them are really there. It's how many more of them are already watching us find the first one.